Hi everyone, welcome to the Ultimate Calculus Guide. In this series, we explore limits, derivatives, and integrals step by step, like a dictionary of rules. Each lesson of this series focuses on a group of related functions, but sometimes I will make proofs for you. And in this lesson, I will make the proof of quotient rule using the limit definition of derivative. And we know that the derivative of a function f of x is equal to limit as h goes to 0 f of x plus h minus f of x over h. And we will prove that the derivative of f of x over g of x is equal to this using the limit definition of derivative. First, let's take our function as f of x over g of x. Our function is f of x over g of x. G of x. And this will be equal to limit as h goes to 0 f of x plus h over g of x plus h minus f of x over g of x and divided by h. And to make this, we will multiply both by g of x, and here we will by g of x plus h. Okay, and this will be equal to limit as h goes to 0 g of x times f of x plus h f of x plus h times g of x over g of x plus h times g of x minus f of x times f of x times g of x plus h divided by g of x plus h times g of x, and all this will be divided by h. Since these denominators are the same, we can write them like this: limit as h goes to 0 f of x plus h times g of x minus f of x times g of x plus h divided by g of x plus h times g of x, and I will write h here. Now I will add and subtract f of x gx from the numerator. I will add here f of x times g of x and subtract f of x times g of x. This does not change anything here. So f of x, I will write this one to here, and this one will stay there. Okay. And this will be equal to limit as h goes to 0 f of x plus h times g of x and minus f of x times g of x and minus f of x times g of x plus h plus f of x times g of x divided by h times g of x plus h times g of x. Okay, let's write this part and this part, and we'll split them. Okay, let's limit as h goes to 0. We have f of x plus h times g of x minus f of x times g of x divided by h times g of x plus h times g of x and minus f of x times g of x plus h and minus f of x times g of x divided by h g of x plus h times g of x. Okay, we have here g of x and here we have f of x. Then we can write this equation like here, limit as h goes to 0, g of x times f of x plus h minus f of x divided by h times g of x plus h times gx. I will write it as here h times, and I will write the other part as 1 over g of x plus h times g of x. Okay, I can write it like that. And then the second part, I will write f of x here minus as f of x times what we have g of x plus h minus g of x over h, and I will write here 1 over g of x plus h and g of x. Okay. And we have gx here, and this is the derivative of f of x. This is equal to f prime of x. And as h goes to 0, this will be equal to f prime x. And as h goes to 0, this will be equal to g prime of x. And as h goes to 0, this will be g of x. And as h goes to 0, this will be again g of x. Then this will be equal to, we have here g of x. Let's write g of x times f prime of x, and we have here square root of g of x, minus we have here f of x times g prime of x, and we have here square root of g of x, and this will be equal to g of x times f prime of x minus f of x times g prime of x over g square of x. And the proof is completed. See you in the next video.